Welcome back to Designing Smarter, Not Smaller. In Part 2, Global Foundries, Amir Faintuch and special guest Linley Gwennap of the Linley Group explore the challenges posed to the semiconductor industry and a smarter path to high-performance, power-efficient AI solutions that go far beyond the limitations of scaling to smaller transistors.
And people ask me, is Moore's law dead? And my honest belief, not just because my background, is that Moore's law is not dead, and there's still at least 15 plus years to squeeze the lemon further on gradual improvements. However, that calls for architectural innovations to complement the process. So the role for GF is to help companies, to help architects with the right tool sets to enable them to complement what they have. So it's not only about the bleeding edge, but we've proven that we can optimize for better memory cells, better VDD at the core goes and up into the multiple IPs that need to be powered up, better tools to optimize performance for very low power consumption, driving solutions below 5 watt, below a watt. You know, when we talk about data centers, you would actually see 20, 15, 17, even 300 watts. But as we said earlier, the innovation starts from the core of the network all the way to the edge. So we also have to optimize and to architect innovations, whether it's at the edge of the network with the mobile devices, to the homes, industrial IoT, etc. GF enables multiple solutions that can actually optimize that, whether it's 22FDX or what we introduce as FinFET 12 LP+, our innovative IPs plus ecosystem IPs to allow you to do smarter die-to-die connection, to allow you to stitch multiple cores to drive lower current, to allows you compact a huge amount of SRAM and drive power consumption by a factor of 2 if you compare it to traditional FinFET architectures.
Yeah, I would tend to agree that the market is looking for power efficient solutions. I mean, we've seen that companies like Tenstorrent presented at our conference, and they're focused at the data center where some of these chips are using hundreds of watts, but really what they've discovered is that that you need to jam as much performance as you can into these high power PCI accelerator cards in order to deliver the best solution for the data centers. But at the other end of the scale, I mean, we certainly see devices that are very small that are targeting applications that run off of batteries even, but they still need to perform these AI tasks in order to deliver new features and services. And companies like Perceive are building tremendous power efficiency into these devices to deliver the kind of AI performance that's necessary for these small devices. So we see the power efficiency trend cutting both ways, from the high end of the market down to the low end of the market.
Correct. And Linley, what was amazing, you mentioned Perceive and others. I always remind myself that AI started first and foremost addressing the computer vision challenge, right, with the ResNets and all the other stuff. But it doesn't stop there. When we think about AI, not only that we're bringing more capabilities around vision, etc., but we're bringing smart to the network. So if you think about that, in a way where we need to help the industry moving is to complement things that are done at the data center level. You think about primarily two major applications, whether it's training or inference. Most of the training today is done at the data center level. And it begs the question, can we and how fast can we enable training at the edge? What should be the core IPs that are needed for a smart camera to run some sets? For instance, if you think about your lawn and you have your squirrels jumping around and going into your geofencing, surely you would like to have some smart at the edge of the network to enable you these applications without actually driving everything into the cloud, etc., etc. And when I was wondering, what is your view about this type of applications, and what do you think is needed by the SoC architectures in order to tap into the next opportunities?
Yeah, I mean, that's a good question. The edge devices are starting to implement inference to get the AI experience down to the end user more quickly. But as you postulate there, we're starting to see more training come into the edge as well. And as training is done at the edge, it helps these devices personalize the experience and better adapt to the needs of each individual. Whether it's an end user or an industrial situation, for example. But that training requires more power of performance to deliver the training capability and more power efficiency. So it even raises the bar higher in order to solve these AI problems.
Exactly. So probably if we just take a linear progression and just take typical architectures and just scale them just with what Moore's law hypothetically delivers, I would like to claim this is necessary but not sufficient. So we have to look back into the Van Neumann equation and to challenge that. And we see more new architectures are coming. Computing memory, actually calculating in analog cells and making sure that you fuse some of these neural networks run on analog bits rather than just by a digital transformation in order to deploy masses of computation in a lower efficiency. As mentioned earlier, at the end of the day, the challenge is performance per watt per cost. So there's more than one solution, more than one architecture to bear. And I trust, working in this industry for so many years, that there's no limit and boundary for human imagination. So I would anticipate and see that it will be an ecosystem that would feed each other. We at the foundry level, we need to bring the right recipes, the right innovation. For example, leveraging SOI as a substrate in order to differentiate, and vice versa, where architects going to challenge companies such as global foundries to deliver more innovative recipes, more IPs, more capability to manufacture at scale and cost in order to address these challenges and opportunities.